All right, and welcome back. In this video, we are going to be going through Chapter 6, Section 3, titled Indirect Proofs. And by the end of this video, we should be able to write indirect proofs in paragraph form. So let's have out our guided notes, and let's begin. So most of the proofs that you have seen or written have been what are called direct proofs. You've reasoned directly from the given to the conclusion using definitions, theorems, and postulates. And sometimes it's difficult or even impossible to find a direct proof. In that case, it may be possible to write what we call an indirect proof. Indirect reasoning is used in everyday life. Consider the following example in which you are trying to convince your neighbor. So you say to your neighbor that my dog Rex dug a hole in your yard on July 15th. Let's temporarily assume that Rex did dig the hole. Then he would have to have been in your yard on July 15th. But I have bills that show Rex was in the veterinarian's kennel from July 14th to July 17th. So Rex couldn't have been in two places at once, and therefore Rex is not the dog that dug the hole in your yard. In an indirect proof, you begin by assuming temporarily that what you want to prove is not true. In the example above, you assumed that your dog dug the hole. And then you went through your statement, you had that little argument with your neighbor, and you showed that by assuming what they wanted to be true was true, you were able to convince them that it actually did not happen. In example number 1, we want to write the first sentence of an indirect proof of each conditional shown. For A, if AB is equal to BC, then triangle ABC is not scalene. For B, if n squared is greater than 6n, then n is not equal to 4. And C, if the measure of angle 1 is equal to the measure of angle 2, then segments XY and CD are parallel. The solution for A: assume temporarily that triangle ABC is scalene. So again, you always assume temporarily of what you're trying to prove is false. B, assume temporarily that n is equal to 4, because again, you're trying to say that n is not equal to 4. You're going to assume temporarily that n is equal to 4. And lastly, assume temporarily that the segments XY and CD are not parallel. With this in mind, please work on problems 1 through 5 on the guided notes and resume when you're ready to move forward. So an indirect proof is usually written in paragraph form. After making the temporary assumption, that's your first sentence, you reason logically until you reach a contradiction of a known fact. And indirect proofs are often used to prove a conclusion that is a negation, such as not equal or not parallel. So these are the 3 steps that we take when we're writing an indirect proof. First step, we're going to assume temporarily that the conclusion is not true. That's always your first sentence. Assume temporarily that da 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 da. Step number 2, you want to reason logically until you reach a contradiction of a known fact. And then step 3, we're going to point out that the temporary assumption must be false and that the conclusion then must be true. You're proving that your assumption in the very beginning is false. So for example number 2, we are given that AC is equal to RT, AB is equal to RS. The angle of A is not congruent to angle R, and we want to prove that BC is not congruent to ST. So our solution is we're going to first assume temporarily that BC is equal to ST. Then that means that triangle ABC is congruent to triangle RST by side, 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 which means that angle A is congruent to angle R since corresponding parts of congruent triangles are congruent. But this contradicts the given because the given says that angle A is not congruent to angle R. So therefore, the temporary assumption that BC is equal to ST must be false. And it follows that segment BC, the length is not equal to the length of segment ST. Please work on problems 6 through 9 on the guided notes. This is a topic that I find students really enjoy because you get to assume in the beginning and then prove something to be false and make those contradictions. And it's quite fun when you make those contradictions within a logical process. So keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.